Hello everyone and welcome to our YouTube channel. We are working on a series of videos on openmp and so far we are on the sixth video right now. So if you haven't checked out the previous ones, please do check them out to get a better idea. And in the last video, we talked about runtime scheduling for the for construct. And in this video, we will be moving ahead and talking about a new type of construct, which is sections. So what exactly is sections? So previously we were talking about the for construct in which we were using a loop and iterating multiple times. So basically dividing the workload to multiple threads via iteration or a for loop. In sections, what we do is we break the workload into separate sections, and each section is worked upon by a single thread while other threads work on other sections. So this is a demo program, and you will get a much better picture when we do the live demo. But just see in the demo program, if you remember, this is the standard prompt for defining any parallel section. So pragma on parallel. So what this does, it creates a certain number of threads, and then I have defined multiple sections. So as you can see, pragma section. So all of these sections are separate from each other. They are individual and unique. So let's start the program, see a live demo of it. I am currently logged in to a HPC Param Rudra, and I'm in the login node right now inside the directory openmp programs. I have stored all of my programs in this directory, and I've loaded a few modules, basically the Intel 1 API compilers for the compilation and execution of the program. Okay, let's compile the program. So before compiling, let me show you the program. This is the program, the exact same one that we saw in the PPT. Okay, now let's compile it. Sections.c. I miss the identifier. I always miss the identifier. Okay. Now we can run this program. Okay. So as you can see, so if you remember from the past videos, when we did not give any kind of limiter, when we did not set any limiter on the number of threads, the program by default resorted to 48 number of threads. But in this scenario, in this situation, only 3 threads were used. Why is that? Because there were only 3 sections to work on. And like I defined in my definition, like I said in my definition for the section construct, a section is executed by only one thread, while the others execute the other section. That is why you see this disparity as well. Okay. Yeah. So if you see, section 2 was completed before section 1. How can this happen? This was only possible because all of these threads were working simultaneously, but all of them were working on separate sections. That is why whichever thread was faster completed the task first and printed first. So this type of construct or work distribution, as we say in openmp, is useful when we want to distribute the work separate the work into multiple chunks and then divide it among threads. In the next video, we'll talk about another type of construct, which is quite similar to the section construct, but a little bit different. Thank you, and do watch the next one.